graduation, sometimes you will be a network administrator, sometimes you will be a network engineer, sometimes you will be a system administrator, system developer, whatever your position. So scalability is something called that we design. We projected. If then assume that you have a classroom here. So they are asking to propose a network design. So you are going there and you see there are 20 students there. So you have 20 computers there. So you will design 20 computer. 20 computer need 24 network switch. Then you want a rack. Then you lay 20 casings there. Then you put cables there. So that is your network. But when you are thinking about the scalability, you have to think about the future expansion. So you have to visit that, and you will see there's another class next to the existing class. So you have to project within 2 or 3 years. Then they will ask for the network for that class too. So you have to think about that expansion. So you can put some extensions to redesign, not a redesign, expand that network in future. So you have to put your switch near to that classroom. That means if there's a wall between two classes, then you have to put your network rack in between those walls. So you can get extension from that. So the cable lengths will be reduced. So you have to think about this. Then that means the scalability is the capability of a network to grow and adapt without major redesign or reinstallation. So you have to consider future expansion at the scalability process. So it seems obvious to allow for growth in a network, but growth can be difficult to achieve without redesign. So without redesign, difficult to. So it seems obvious to allow for growth in a network, but growth can be difficult to achieve without redesign. So if you are not doing scalable design at this initial stage, so you will have to consider about the redesign and reinstallation. So the redesign may be significant and it will be costly. So you have to put some money, then more than you are expected to create the network. So most organizations cannot afford to recable or redesign the network when users are relocated, new nodes are added, or new applications are introduced. Due to the current situation, due to the COVID situation, so the prices are going up very quickly. So some companies, that means they take the project when they will take project in last year. So within 1 year, they are not able to do the project. So they will move out of their project. So because they cannot afford cables and they are not able to redesign their network due to the prices. So we have to think about that. Anyone have any question? If you have any clarification, please ask.
Yes, sir. Yes.
ඇයි අපි network එකක් scalability එක ගැන consider කරන්නේ?
Considering about future extending.
Sorry?
Considering about future extending our networks.
All right, okay. So when we are expanding our network, so we will talk about the sizing, then our human resources. So we have to consider about this. So the need to scale the network. So these topics are similar, but you sometimes you see that the points are also similar each other. So you have to get the brief idea on this scalability. The need to scale the network. As business grow and evolve, they hire more employees, they open branches and expand into global markets. So when the businesses grow, they will hire more employees, open branch offices, and expand into their businesses to global markets. So these changes directly affect the requirement of a network. A large business environment with many users, locations, and systems refers to as enterprise. If there are large environments with many users and geographically different locations, and there are a lot of systems, then it refers to as enterprise. So the network that is used to support the business enterprise called the enterprise network. If you have a hardware or you have a two-story building, that is not an enterprise network. So when you think about the enterprise network, it has large environment with a lot of users, a lot of locations. They have a lot of branches all over the country and all over the world, and they have a lot of systems. Sometimes the ERP, sometimes the relevant systems, account systems. So if the systems consist of all these, the enterprise that consists with all these things, then we call it as an enterprise network. The following steps occur as a network grows from a small company to global enterprise. So the following steps occur when you are growing your businesses to the global enterprise. So the company begins as a small single location company. It's like sometimes the online business. Then the increased number of employees, and the company grows to multiple locations in the same city. So you expand your. This is the way you expand your business. Then the enterprise grows to multiple cities. Then you hire teleworkers. Who are the teleworkers? The teleworkers who work currently, we consider work from home people. They have internet, they have a computer or laptop, mobile. Then they are teleworkers. They are work from home. So the enterprises hire teleworkers, call centers, and support services. They will hire teleworkers. So then the enterprise expands to other countries. And all enterprises are international. That means some companies have overseas businesses, some local only. So enterprise network centralize the network network operations. So finally, the network operation is centered there. So they centralize all the network into one location. So they are managed their enterprise to that location. That will be called network operation center. The enterprise network must support the exchange of various types of network traffic, including data files, emails, IP telephony, that means PABX, so video applications for multiple businesses. So you all know about this. So all enterprise networks must support critical applications. So every business have a critical applications, like sometimes the ERP, sometimes we talk about the air traffic controlling, the railway traffic controlling. So they are the critical application. So electric power grid systems, like that. So those are critical applications. So all enterprises should support converged network traffic. So converged network traffic means mainly data, voice, and video all coming to the single network. So the network traffic should the enterprise network support converged network traffic. If someone need the data, someone need a voice, someone need a video. So the enterprise network should converge network traffic. So it should support diverse business needs. Diverse business needs means if you think about the company, there are different type of people, male and female, so different age limits, different religions people. So the diversity is the refers to the organization that intentionally employs workforce comprised of individuals with a range of characteristics such as gender, religion, race, age, ethnicity, sexual orientation, education, like that. So diverse means it depends on the race, age, then their gender, their education level, like that. So all the enterprise network must provide centralized administrative control. So the enterprise network must contain all these four: critical applications, converged network traffic, diverse business needs, and centralized administrative control. So enterprise business devices. So users expect enterprise networks to be up 99%. That means it's around 100% of the time. Outages in the enterprise network prevent the business from performing normal activities, which can result in a loss of revenue, customers, data, and opportunities. That means if a single point of failure, the network, the result will be loss of revenue, customer, loss of customers, loss of data, and loss of opportunities. The similar thing is, I think 3 to 4 months ago, the Facebook had down for 5 or 6 hours. Then they lost billions of rupees, billion of dollars, and also they have that means they have missed some opportunities. Their businesses goes down. So single point of failure will affect to the revenue, customers, data, and their opportunities. So this is some background of the enterprise network. So it has WAN, wide area network, telephone systems, internet. So they have remote large sites. Their sites have services like data centers, services blocks. So their main site, and they have remote sizes, remote medium sites, remote small sizes. This is a large enterprise network. So they have different types of connectivity, different types of technology. So to obtain this level of reliability, high-end enterprise, that means class equipment is commonly installed in the enterprise network. So to take this reliability, we use high-end enterprise class equipment. So anybody tell me about the enterprise class equipment that you know about? High-end enterprise devices, if we consider about the switches or routers.
And server.
Sorry?
Server.
So yeah, servers are the high-end enterprise devices. So high-end enterprise class equipment, that means when we are creating a network, we think about that's coming to our mind, that is Cisco. You know, the Cisco network is good. Okay. Then you will remember the HP routers like that. Did you hear about this? HP? What about the Huawei?
Yes.
Okay. Then
Yes.
yeah. Then we have different types of vendors. So Cisco, whatever, the Juniper, HP, or the Huawei, they are also in the market. So we obtain, when we are talking about the reliability, so we are talking about the high-end enterprise class equipment. So we are not using TP-Link switches or routers. So in a classroom or in a house, we can use a TP-Link, but in the huge enterprise, we are not using that kind of devices. So we use Extreme switches also there, extreme routers there, Cisco, then HP, then Huawei, like that. So enterprise class equipment is designed for reliability. So reliability is the main feature of the enterprise class equipment. So they have redundant power supplies and failover capabilities. That means, what does it mean? The redundant power supplies mean, and the failover capabilities. That means if we have a router in a network, sometimes it's called the core router. So what happens if it is failed? If it is failed, the total network will be down. So those devices have redundant power supply. So I think you know about it. Huh? Have you seen any device with the redundant power supply? Still, with the same Prematilaka, Hasmanage, who are in the chat can talk. Have you ever seen redundant power supply devices?
No, sir.
No.
Some images I
Alright,
see before in internet.
Okay, we will see. I will check with the network department. I think we have some equipment to practice and to visualize. Otherwise, not point of having a network, you know. So I will check with them because we need some devices to physically see. Otherwise, you will go to the industry, then you will be sorry for that. Huh? When you are in the market, job market. So I think you have to better see, and you have to touch, and you have to work with them. So some routers and switches have redundant power supply. That means there are two power supplies in it. So when the one power supply down, so you can remove it while the switch is working or router is working. So you can replace it while it's working. So there's no effect to the network. So those are the redundant power supply. If it's a desktop machine, then we have to shut down it and change the power supply. But but we are talking about the routers or sometimes the switches. They have redundant power supply, so it creates the reliability. So if the one power module down, you can remove it while the router or the switch is live. So you can remove it and you can replace it. So that is the redundant power supply. Then it addresses the failover capability. So purchasing and installing enterprise class equipment does not eliminate the need for proper network design. The purchasing and installing enterprise does not does not eliminate the need for proper network design. So I will check this. Purchasing and installing enterprise class equipment does not I think the statement is not okay, so I will remove it in presentation. So design for scalability. This is sometimes some statement. So I will talk to you. To support an enterprise network, the network design must develop a strategy to enable the network to be available and to scale effectively and easily. So use expandable modular equipment and or clustered devices. Use expandable modular equipment. What is modular equipment? I think some statements, some sentences are common to you. Everybody know about this. So I will take some words and I will ask questions from you. What is modular equipment? Have you seen Cisco routers or Cisco switches physically?
No, sir.
Hmm?
No, sir.
No. All right. Okay. Cisco devices, they are coming in a basic level. So you have to purchase modular wise. So basically it comes to Ethernet interfaces. So if you want to increase it to 4 or the fiber interfaces, so you have to purchase modulars from them, and you have to fix it to the router or the switch. So those are modular equipment. So you can expand your switch or router using those modulars. So there are other things is clusters devices. Clusters means
excuse me, sir.
oh sir.
මේ අර මොඩියුලර් ඉක්විප්මන්ට් කියලා කියන්නේ එතකොට අපි අර ගන්න ස්විච් එක මොඩිෆයි කරලා දාන්න පුළුවන් එකද?
ඔව් ඒව තමයි මොඩියුලර්. දැන් අතන අපේ network එක expandable වෙනවා කියන එකේදී අපි දැන් switch එකක් තියාගෙන expand කරනවා නම් අපි තව switch එකක් ගන්න ඕනේ.
ඔව්.
දැන් අපි modular equipment කියන්නේ මේකට පුළුවන් මොඩියුලර් කියන්නේ අපි modulars කියන්නේ modules කියන එකනේ. එතකොට අපිට පුළුවන් දැන් router එකකට switch එකකට ගත්තම දැන් basic Cisco ASA firewall එකක් තියෙනවා. ඒ router එක කියමුකෝ. එතකොට ඒකනේ basic firewall Cisco packet tracer එක කරලා තියෙනව නේද?
ඔව් සර්.
ඒක ඔයගොල්ලෝ මේ down කරලා add කරලා තියෙනද modules එක ඉස්සර මේ routers වලට switches වලට.
ඒ කියන්නේ ports එහෙම නේද?
ඔව් ports වල fiber ports එක. ඒක කියන්නේ
එහෙමනම් කරලා තියෙනවා.
තියෙනවා. ඒ වගේම physically අපිට modules මේ add කරන්න පුළුවන් switches වලට, routers වලට. දෙකටම. එතකොට ඒ equipment තමයි දැන් module equipment කියන එක. ඒ කියන්නේ මේවට අපිට expandable කරනකොට modules plug කරන්න පුළුවන්. එතකොට දැන් ඔයාලට පුළුවන් Cisco switch එකක් නම් ඒකට පුළුවන් fast Ethernet port තියෙනකොට ඔයගොල්ලෝ gigabit Ethernet ගන්න ඔයගොල්ලෝ කරන්නේ මොකද්ද? ඒකට අදාළ module එක අරන් දාන එකනේ කරන්නේ. fix කරන එකනේ. එතකොට ඒ විදිහටම කරන්න පුළුවන් එක තමයි අපි කියන්නේ module equipment. එතකොට මේව තමයි අපිට easily upgrade and to increase the capabilities. Because without expanding our network, without expanding too much. So if we needed 2 switches, assume that you have 8 ports. So your switch has 4 ports. This is a assumption. Okay? So if you have purchased a new switch, then you have to purchase. You have to spend similar price. So you can purchase a module less than that price. So one switch you can use as a 8 port switch. So you can only you have to only add modular to that switch. So device modules can be added to the existing equipment to support new features and device without requiring major equipment upgrades. Some devices can be integrated in a cluster to act as one device to simplify management and configuration. So design hierarchical network to include modules that can be added, upgraded, and modified as necessary without affecting the design of the other functional areas of the network. For example, you can create a separate access layer that can be expanded without affecting the distribution and core layers of the campus network. So in next presentations, we will talk about the hierarchical architecture. So in hierarchical network, so you can include modules that can be added to upgrade your different layers there. So you can separate your layers by expanding without affecting the distribution or the core, whatever the access layers in your campus network. So further to that, you can create an IPv4 or IPv6 address strategy in a hierarchical manner. So careful address planning eliminates the need to re-address the network to support additional users and services. So that means when you are creating a network, you have to think about your network distribution. So you have to assume how many numbers, how many students, or how many lectures, how many staff using internet. So floor-wise, you have to distribute it. You have to divide it. Assume you have a 4-story house, a building. So in each floor, it has 20 staff members. Then you have to assign you have to decide what is the IP addresses that you have to take, and what is the subnet mask, and what is the gateway that you have to use. If you are using a higher subnet mask, then the IP addresses will be useless. That means you have 20 devices, but you put 24 subnets. So then 255 devices allocations there, but you use 20 IP addresses. So that is a waste of IP addresses. So you can carefully plan your IPv4 or IPv6 addresses. Anybody ඔයගොල්ලෝ කොහොමද subnetting ඒවා ටික කරලා තියෙන්නේ නේද?
Yes, yes.
Okay. So the choose routers or multi-layer switches to limit broadcast and filter other undesirable traffic from the network. So you will use layer 3 devices to filter and reduce traffic to the network core. Choose routers or multi-layer switches to limit broadcast. So you can decide what type of routers or the multi-layer switches, that means not L2, this L3 switches, how to use them to limit the broadcast and filter undesirable traffic that goes out from your network and comes to your network. So use layer 3 devices to filter and reduce traffic to the network core. All right. So we talk about the scalability. That means scalability is required. So we have to think about the device, how to use devices, how to use IP address, how to make, how to create, how to design extensions for the expansions, then how to manage your IP addresses, then how to use L3 and L3 switches and the routers properly in your network. So those things are have to understand in the scalability in your network. So when we are talking about the scalability, there are hierarchical design models. So you can divide your network into that model. So it is easy to understand what is the fault in the network. So what type of device you need to create the network. So in which layer that problem is occurs. So to identify there is a conceptual model there, that is hierarchical network design model. So it's a conceptual model. So you can divide your network into that hierarchical model, so you can easily resolve the matters pertaining to you when you are in the field. So you have a problem in the user level, then you will know it is the access layer issue. If you have a internet problem in the main area, that means the core layer. So you can identify your network problem by this, considering by this hierarchical network design model. So it's a 3-layer hierarchical design model. So its design model breaks this more complex problem of network design into smaller and more manageable problems. So your network is breaking into smaller and manageable problems. So each level over here in the hierarchy address a different set of problems. So this helps the designer to optimize network hardware and software to perform specific roles. So the traffic stays local and is not propagated unnecessarily onto the other portions of the network. So hierarchical model, the complex problem divided into smaller and manageable problems. Then you will know the different set of problems. Then it will help to optimize your network and software performances in specific layers. So another thing is it not propagates unnecessarily traffic to other portions of network. If it is about the distribution layer, it is not propagate to the core layer. If it is the access layer, then it will not propagate to the distribution layer. So this is the hierarchical model that we are talking about in scalable network. So in the 3-layer network design model, network devices links are grouped according to 3 layers. So there are 3 layers. One is core layer, the distribution layer, and the access layer. flow layer is high-speed switching. So distribution layer is a policy-based connectivity, and access layer is a local and remote per group access. So this three-layer model is conceptual framework. Anybody who write down these on your books or the paper? කවුරුද මේවා ලියා ගන්නවද නේ? නෑ ඔයාලා ප්‍රසන්ටේෂන් එක කරන්නේ නේද?
ඔව් ප්‍රසන්ටේෂන් එකයි වීඩියෝ එකයි බලලා තමයි අප්ලෝඩ් කරන්නේ.
ඔව් මම මේක එඩිට් කරලා තව දෙන්න මම තව මේක ඇඩ් කරන්න දේවල් තියෙනවා ප්‍රසන්ටේෂන් එකේ. ඒ ටික මම මේ කතා කරේ hierarchical design එක ගැන. hierarchical design එක ඔයගොල්ලෝ network architecture කරලා තියෙනවද කලින්? architecture network design part එක කරලාද ඔයගොල්ලෝ?
network architecture එක subject එකක් තිබ්බද මේවා කරේ නේද?
මේ network design එක මාකට implementation හරි මාකට කියන subject එක?
ඒක තියෙන්නේ මේ sem එකේ.
මේ sem එකේ තියෙනවා නේද? තමයි මේකේ in depth එකේදී කතා කරන්නේ. මම මේකදී ඇත්තම routing වලට නිකන් scalable network කියන නිසා අපි මේ ටික කතා කරන්නේ. ඊට පස්සේ මේක ගොඩක් වෙලාට වැඩි දුරට කතා කරයි network implementation. Then so there are three layers: specific layers, core layers, distribution, and access layers. So it's a conceptual model. So this is some image that shows how the core, distribution, access, and how the internet is working there. In three-layer hierarchical design models, the layered models are useful because they facilitate modularity. That means you can the modularity means the also called groups, clusters, or the communities. The modules can be removed, replaced, or upgraded without affecting other components. So devices at each layer have similar and well-defined functions. And also this allows administrators to easily add, replace, and remove individual pieces of the network. So the network administrator or engineer will be able to sort out the problem layer by layer. So if we know the problem, then they can sort out. If it is access layer, then he can consider about the access layer devices. If it is a distribution, then they can talk about the distribution layer device. So this kind of flexibility and adaptability makes it hierarchical network design highly scalable. So the three-layer hierarchical design, the access layer provides connectivity for the user. So if you are in a university or if you are in a tea shop, whatever location, so you are accessing the access layer in the network. So the connectivity for the users are addressed by the access layer. The distribution layer is used to forward traffic from one local network to other. That means it's based on policies, policy-based connectivity made by distribution layer. So finally, the core layer represents a high-speed backbone layer between different networks. So three layers have different capabilities. So the user traffic is initiated at the access layer and passes to the other layers if the functionality of this layer is required. So it's transferred from access to core layer. So even though the hierarchical model has three layers, some smaller enterprise networks might implement a two-tier hierarchical design. So conceptually, there are core, distribution, and access layer. But theoretically, you have to know. But when you are in an industry, sometimes they don't have core and distribution layer. They have access layer, but that means they collapse into one layer, the core and the distribution. So some networks, some enterprise networks doesn't have three layers as a theoretical hierarchical level. So you have only two layers. That means access layer. Yeah. So, and the other thing is sometimes we call it as a core layer. We are not talking about the distribution layer. So in two-tier hierarchical net design, the core and the distribution layers are collapsed into one layer. So it will reduce the cost and the complexity. So the network administrator have to address two layers. One is access, and the other one is generally we call it a core layer. So there are two. In a practical scenario, a lot of companies have two layers. So the core layer provides an optimized and reliable transport structure by forwarding traffic at very high speed. So core layer consider about the optimization and reliable transport traffic to next destination. In other words, the core layer switches packet as fast as possible. That layer consider about transferring data fast as possible. So devices at the core layer should not be burdened with any processes that stand in the way of switching packets at top speed. So it's not considered about the access list checking, data encryption, address translation, not considered. So the core layer is always targeting to switch packets as fast as possible. In the distribution layer, it's located between the access and core layer, and it helps differentiate the core from the rest of the network. So it differentiates the core and the access layer, and it lays between the core and the access. The purpose of this layer is to provide boundary definition using access list and other filters. So that layer is based on the policies. So it's using access list and other filters to limit what gets into the core. So when the traffic comes from the access layer, so in a distribution layer, they have access list and different types of filtering policies there. So they will filter the traffic and send it to the core layer. So therefore, this layer defines policy for the network. So a policy is an approach to handling certain kind of traffic, including the following. So policies that we are using in a distribution layer to reduce the traffic forward into the core layer. So we use routing update, route summarize, so VLAN traffic, and address aggregations to aggregations at the distribution layer. So use these policies to secure network and to preserve resources by preventing unnecessary traffic. So we use these policies to secure network, and we prevent unnecessary traffic transferring from layer to layer. The access layer supplies traffic to the network and perform network into control. So end users access network resources by way of the access layer. So end users are in the access layer. It is a wireless or a wired. It's acting as a front door to a network, and the access layer employs access list designed to prevent unauthorized users from gain entry. So use in access layer, you put some access list, like you put Wi-Fi login, you put Wi-Fi captive portal, sometimes you put restriction policies to access the internet, access the network. So acting as a front door to a network, the access layer employs access list designed to prevent unauthorized users from gaining entry. So the access layer can also give remote site access to the network by way of wide area technologies such as frame relay, ISDN, or leaf spine. So access layer sometimes give remote site access using the frame relay, ISDN, or the leaf spine. So router functions. So that is about the hierarchical architecture of a network. So router function. So in this topic, we are talking about the Internetwork Routing. So sometimes we talk about some theories based on the network. So consider about the routing. The router function is the hierarchy. So the core, distribution, access layers each have clearly defined functions. For this reason, each layer demands a different set of features from routers, switches, and links. So each different layer has routers, switches, and different links. Routers that operate in the same layer can be configured in a consistent way because they all must perform similar tasks. So if the devices in the same layer, they configure in a consistent way because they all must perform similar tasks. The router is the primary device that maintains logical and physical hierarchy in a network. So therefore, proper and consistent configurations are imperative. So router function in the hierarchy continue. So when we are talking about the router, there are Cisco, Huawei, HP, Juniper, whatever the router is. So each product line has particular set of features for one of the three layers. So in 4 layers, this one, the Catalyst 85000 series, NCS 57000 series are the core layer routers. So 12,000, 7,200 sometimes is a little bit obsolete routers there. So, but remember the numbers. Now we have Catalyst 8500 series, NCS 5700 series. And when we think about the Huawei, we have NE 9800 series routers. In a distribution layer, we have 4500 series. In access layer, we have Cisco ISR 900. So 2600 is a little bit older one. So these are some devices, router devices series. I missed the question. So this is the core. Core has high-speed switching, WAN backbone, and in distribution layer, we have area aggregation, VLAN routing, and security. So that means it's based on the policies. And in access layer, we have work group, dial-in, telecommunicators, that means work from homes, and branch officers. So those are the 3 layers that we discuss on a hierarchical model. So shall we have any questions? කාට හරි මොනවද දෙයක් තියෙනවද මේක අපි දැන් මේ ටික බේසිකලි ගත්තේ සමාජයෙන් වල පොඩි පොඩි ක්ලැරිෆිකේෂන්ස් තියෙනවා අහන්න. ඔක්කොම ප්‍රශ්නද?
විතර ප්‍රශ්නයක් නෑ.
මේ බේසික් කලින් නම් මේවා දන්නවනේ. එතකොට අපි ප්‍රැක්ටිකල් වලට තමයි ඉස්සරහට බේස් කරන්න ඕනේ වැඩිම. බලමු මම හිතන්නේ lecture hours තියෙන්නේ එකට 25 hours lecture hours, then you have 25 practical hours and 10 for 10 for what? So you have only 60 hours, so 25 hours for practical. So how did you do your switching practicals on at home, or you visited the you know that?
No practical.
Huh?
Simulation tool only, like packet tracer.
Packet tracer.
කිසිම ලැබ් ප්‍රැක්ටිකල් එකක් එවන කරේ නැහැ කියන්නේ මේ කැම්පස් එකේ නම් මොකක් කරේ නැහැ.
මේ ලැබ් එකේ අයිටම් මේවා තියනවා නේද? පඩු මම හිතන්නේ.
මේක නම් අපි දන්නේ නැහැ සර්.
පඩු නම් නැහැ සර්. දැන්
Cisco lab එකේ තියනවා නේද? routers switches
devices නැහැ සර්. අහලා බැලුවා. devices ටික නැහැ ඒක
ඒක සර් කෝකටත් තාලා බලන්න සර්. ඉතින් ඒක
I will check මොකද අපිට devices වලට access කරනවා දැන් you will know how to work with the power packet tracer, but do you know how to access the switch or the router via the console cable? Do you know physically?
No.
You never try, no?
No.
So you better to know about those things when you are in the market, because they are when they are interviewing, they are asking technical questions, but sometimes you have knowledge on how to do a practical. So if you are in the job market, then they will say reset this switch or the router, then you only know about the packet tracer. So very difficult to defend yourself in the network market. So we will try to do it. So I think at that time we had the practicals in the Cisco lab there. We will check. At least we will divide you into different groups. Then we have 12 students or 50.
Maximum sir 15, but also in the 14 students are daily attending to the lecture. If there is not power cut.
All right. Okay. Let's see. We will sometimes divide into 2 groups, and we will call up you to the UOEC. Then we will try to do some practicals, and that is better.
In the last 3 sem, we have no actual physical practical anything.
All right. Okay. We will try. When will the semester end?
I think
start on 12th, then will end on?
I think September.
Yeah.
There is 1 month student leave also available.
In September.
Yeah, we have to go industrial in October.
You have industrial next year, no?
Yeah.
All right. Okay. So you have to know something about this thing. Otherwise, difficult to find the industry market. You have to create some CVs there. Curriculum it is so with the subject, no? Okay. We'll try. So these are the basics what we talk about the scalability of network. So
Excuse me, sir.
Sorry.
Sir, there is power down. My computer is going to die, and shall I leave?
Okay. You can leave. All right. Okay. All right. We have a lot of presentations there, but I talk about the important slides on that presentation. So then we will talk about the key characteristics of scalable internet. So those are the key characteristics that we have to understand in this scalable internet. So there are 5 characteristics. One is reliable and available, the responsive, efficient, the adaptable, and the accessible but secure. So when we talk about the reliable and available characteristics, a responsive network should provide quality of service for various applications and protocols. So quality of service means it controls traffic and ensure the performance critical applications with limited network capacity. So quality of service means it should control the traffic and ensure the performance of the critical application. It depends on the what. Sometimes it's voice over, or sometimes the data. So sometimes it will be the data or voice. So the other thing is data, voice. And the other thing is it should be responsive. A responsive network should provide quality of service to various applications protocols without making responses at the desktop world. So it should be responsive and it should be efficient. Large internet networks must optimize the use of resources, especially bandwidth. It is possible to increase data throughput without adding hardware or buying more WAN services. So it should be efficient. So it is possible to increase data throughput without adding more hardware or buying more WAN services. So WAN services mean you have to take your internet service from the ISP or whatever the lease line provided. So to do this, reduce unnecessary broadcast, service location requests, and routing updates. So when you are optimizing your bandwidth, you have to think about your internal network. So you have to identify your unnecessary broadcast, your some location requests that transfers to the network, and how to manage your routing update. So efficient is another characteristic of scalable network. The other thing is adaptable. An adaptable network can accommodate different protocols, applications, and hardware technologies. So an adaptable network can accommodate different protocols and different type of applications and different type of hardware technologies. Means the scalable network should adapt with the protocols, applications, and the hardware technologies. And other thing is accessible network allows for connections using dedicated dial-up and switch services while maintaining network integrity. Integrity means the data is protected from unauthorized changes to ensure that it's reliable and correct. So integrity is protecting data from unauthorized changes. So those are the 5 characters: reliable and available, responsive, efficient, and adaptable. The last one, accessible but secure. So making the network reliable and available. A reliable and available network provide users with 24 hours a day, 7 days a week access. That means 24/7 available network. In a highly reliable and available network, fault tolerance and redundancy makes outages and failures invisible to the end user. So highly reliable network has fault tolerance options. The fault tolerance means if we have one single router there, so if it is failed, then total network fails. So the enterprise level network use 2 switches, two routers. So if the one router fails, then the data will transfer to the failover devices. So one is failed, then the data will transfer to the other devices. So mainly the companies have one firewall, but enterprise level they have 2 firewalls, 2 routers. So whenever one fails, traffic will transfer to the other router or the firewall, but the failure invisible to the end user. So they are not able to identify what was happened there. So the high-end devices and telecommunication links that ensure this kind of performance come with high price tags. So for devices, and telecommunication links to ensure this kind of performance will be very costly. So network designers constantly have to balance the needs of users with the resources at hand. So if you are a network designer, you have to understand the resources that having with you. So we have to design it. You have to design it properly, and further to that, you have to identify the resources that you have.
No problem, sir. It's okay.
So when making network reliable and available, when choosing between high performance and low cost at the core layer, the network administrator should choose the best available routers and dedicated bandwidth. So if you, when you are a network administrator or an engineer, so you have to think about the best available routers and the dedicated bandwidth. And the core must be designed to be the most reliable and available layer. The core router fails if the core link becomes unstable. Routing for the entire internet traffic might be adversely affectable. So you have to think about it. So core routers maintain reliability and availability by rerouting traffic in the event of failure. So robust networks can adapt to the failure quickly and effectively. Robust means minimizing the variations in network performance, such as average delay or a throughput due to the different perturbations in the network. That means, examples of topology or demand and the community of interest. So core routers, robust networks can adapt the failure quickly and effectively. To build robust networks, this is about the Cisco EOS, offers several features that enhance reliability and availability. So build robust networks, that means not delayed or not that means not it degrades the performance. So this kind of networks have several features to enhance reliability and availability. So it supports for scalable routing protocols. So sometimes it has alternative paths, and it has load balancing, so protocol channels and dial backup. So what it means, support for scalable routing protocols? It means we have to think about the protocol that we have to use in your network. So to that, or in alternative path, you have to think about alternative paths. If you have a building, if you have a single path from ground floor to first floor, second floor, third floor, whatever the damage happened to a cable, then it will affect your total network in the second floor, whatever the first floor. So alternative paths should be there. So if the one point of failure, then the data will be transferred to the other path. So you have to think about it, the alternative path. And other thing is load balancing. So you can use different network lines. So you can balance your network. That means you can balance your traffic. And the other thing is here, protocol tunnels. In the protocol tunnels, sometimes we talk about like this. Protocol tunnels and the dial-up backup. Dial-up backup means generally we have lease VPLS connections, a lease line. So if the lease line fails, then the total internet connectivity drops. So we have to keep dial-up backup. That means it will not cost much. So we can keep dial backup for your network. If the main lease line down, then the traffic will go through a dial backup. So we don't want to buy two lease lines because we have to pay high cost to maintain two backup two lease lines. So we have to better keep a dial backup for enhance the reliability and availability. So to build robust networks, we have to think about scalable routing protocols, alternative path, load balancing, protocol tunnels, and dial backups. So these are the briefing of the network. So I think enough for you. Then those presentations have the descriptions of those wording. I think you can get the information through that slide. So you can go through them. I will share after edit some slides. I think is it better, no?
Yes, sir.
Do you want to read all the slides, or I will tell the relevant slides, then you can get the information from the other slides, no? is it better?
Yeah, okay, that's no problem.
නේද නැත්නම් මේ සයිස් එක අහගෙන නිදි මතත් වෙනවා නේද මට පේන්නේ නැහැ කවුරුත්. හරි අපි එතකොට අද දවසේ මොනවද කතා කරේ අපි? සමරියක් මට සුට්ටක් නිකන් කියන එක අයිඩියක් මට මේ වචන ටිකක් හරි කියන එකක් කියන්න මම අයිඩියා එක ආපු ඉතින්
network එකක් design කරනකොට ඒකට network එකක් scalability විදියට design කරන්න කියලා purpose එක මොකක්ද කියලා කතා කරනවා.
ඔව්. ඕකේ අපි දැන් මේකදී කතා කරේ scalability network එකක් කොහොමද කරන්නේ ඊට පස්සේ ඒකෙදි බලාපොරොත්තු වෙන්නේ මොකද ඊට පස්සේ ඒකේ තියෙන hierarchical කියලා model එකක් ඒ කියන්නේ conceptual model එකක් ඒකෙදි අපි core distribution access layer කියලා කොහොමද අපි ඒක බෙදාගන්නේ ඊට පස්සේ ඒකට අනුව අපි කොහොමද ප්‍රශ්නයක් විසඳන්නේ network එකේ තියෙන problem ඒ කියන්නේ case study එකක් කොහොමද විසඳන්නේ කියන එක අපි කතා කරා ඒතර core layer එක කතා කරන්නේ නැත්නම් traffic එකක් එක endpoint එකකින් නම් තව network එකකට වෙන්න පුළුවන් transfer කරන එක. core එකෙන්. ඒත් access layer එකේදී අපි කතා කරන්නේ user කෙනෙක් computer එකෙන් හරි log වෙලා phone එකෙන් හරි log වෙලා ඒ වැඩේ කරගන්නේ කොහොමද කියන එක. ඊට පස්සේ distribution එක කතා කරන්නේ ඒ user අපි policy wise control කරලා යාව කොහොමද අපි core එකට යවන්නේ කියන එක. core network එකට access යාට දෙන්නේ කොහොමද කියලා අපිට මෙයාව filter කරනවද නැද්ද කියන එක තමයි අපි distribution එකේදී කතා කරන්නේ. distribution එකෙන් core එකට ඒ policy base අනුව traffic එක maintain කරලා එයා core එකට දෙනවා. ඒතකොට actual world එකේදී ගොඩක් කරලා දැන් ගොඩක් companies layers තුනක් maintain කරන්නේ cost එක යන හින්දා. ඒක මොකද cost එක තමයි company එක main address කරන දේ. කියන්නේ මුලින්ම company බලාපොරොත්තු වෙන income එක සහ වියදම අඩු කරන එක තමයි බලාපොරොත්තු වෙන්නේ. ඒකට ඒකෙදි core and distribution එක maintain කරනවද දෙකම එකක් මිනිමම් maintain කරනවද කියලා network එක කරන අය decide කරනවා. ඒකට ඒ layers තුන ගැන කතා කරා. ඊට පස්සේ අපි ඒකෙදි කතා කරා key factors කීපයක් reliability ඊට පස්සේ efficient ඊට පස්සේ තව අපි කතා කරා reliability ඊට පස්සේ responsive වෙන්නේ කොහොමද efficient වෙන්නේ කොහොමද ඊට පස්සේ adaptable වෙන්නේ කොහොමද network එක ඊට පස්සේ secure වෙන්නේ කොහොමද කියන එක අපි characteristic කතා කරලා මේක තමයි basic network එකේ scalable network එකේ details එක. මම අතට presentation එක share කරගන්න. ඔයගොල්ලෝ මේක බලන්න. එතකොට අපි ඊළඟ සතියේ විනාඩි 10ක් 15ක් කරගෙන මේක ගැන roughly කතා කරලා ඊට පස්සේ අපි protocols ගැන next week කතා කරමු.
Okay.
විදුසුන්ද මේකේ මේ post මේ මෙයන් කවුද representative ඉන්නේ badge එකේ?
අපේ
කවුද කරන්නේ? කරන්නේ. හරි. මේ අදට අපි මේවා කරමු. ලබන සතියේ කලින් මම කන්ෆර්ම් කරනවා 8:30 තමයි තියන්න ඕනේ. ඔයාලට කතා කරමු ලින්. ඊයේසෙට කතා කරමු. හරි. හරි. මොකද ඉතින් දැන් ප්‍රශ්න තියෙනවද තේරෙන්නේ නැද්ද? පැහැදිලි නැද්ද? මොකක්ද තියෙන දේ කියන්න මට පුළුවන් ඊළඟ ප්‍රසන්ටේෂන් වලදී ඒක තව ටිකක් ඉම්ප්‍රූව් කරන්න. ක්ලියර්? අපි ඉස්සර කාලේ කලාව වගේ තමයි නේද? හැම දෙයකම ක්ලියර්ලි එකකින් ඉන්නවනේ.
මක්කරන්න නැහැ සර් අපි බලමු මේ ප්‍රැක්ටිකල් කරගන්න පුළුවන් නම් හොඳයි සර් මේ සබ්ජෙක්ට් එකෙත් මේ අර සර් කිව්වා වගේම
ඔව් බා.
සර් පොඩක් මේ පැත්තෙන්
නෑ මම try කරනවා බේසික් මොකද මම දන්නවා ඉතින් මේකේ ටෙක්නිකලියට මේ බලන්න කොහමද ප්‍රැක්ටිකල් ටිකක් කරගන්න. ඔය මේ පැකට් ට්‍රේස් නම් ඉතින් හැමදාම කරන්න පුළුවන්. නෝත් අර ලයිව් ඒක පොඩ්ඩක් හරි අත ගාලා දුන්නොත් at least ස්විච් එක වතඳුරනවා නේද? රවුටර් එක වතඳුරනවානේ. මොකද මාකට් එකට ගියාම ඉතින් ඉන්ඩස්ට්‍රි එකේදී ලොකු වෙනස්කම් තියෙනවා. අපි මොකද ෆිසිකලි මෙතන ඉඳන් අපි රවුටර් එකක් ඔන් කරලා ඔෆ් කරනවා වගේ නෙමෙයි එන්වයරන්මන්ට් එකේ. ඔයාලා ගිහලා කම්පැනි එකේ රවුටර් එක හදිස්සියට ඩවුන් කරොත් ගෙදර යන බලාගෙන තමයි ඩවුන් කරන්න ඕනේ. ඒ වගේ ප්‍රශ්න තියෙන කෙනෙක් අපිට මෙහෙදී නම් ඕන දෙයක් කරන්න පුළුවන්. ඒකට at least මේ කොහොමද ඒක පාවිච්චි කරන්න කියලා ඉගෙනගෙන තියෙනවා. අපි බලමු කොහොමද කරගන්නේ. ඒක එහෙම කරමු. අපිට මේ අවස්ථාවේ පුළුවන් රෙඩ් හැට් එකක් කට්ටියමද කරන්නේ?
තව ඉන්නවා සර් සෙට් එකක් වෙන්න.
මම හිතන්නේ ඔයාලට පෝස්ට් fee එක අඩු කරලා අපිට ගන්න පුළුවන්. ඒ කියන්නේ තව ගොඩක් අඩු කරලා.
අපේ දැන් අරගේ අර මම දාපු ගෲප් එකේ සර් 30ක් විතර ඉන්නවා. 30කුත් මේකේ 30 ඒකනොත් හැබැයි ඉතින් අපි අර කෝස් fee එක ගැන කිව්වහම කරන පිළිස කොහොම වෙයිද කියලා කියන්න බෑ කොහොමත් එක්ස්ටර්නල් එකට වැඩිය 35 දෙනෙක් ඉන්නද නේද ගෲප් එකේ මම අර ප්‍රසන්ටේෂන් එක කර කරන්ට් ගැන හින්දා ප්‍රසන්ටේෂන් එක ඒක මම කරලා දැම්ම ඒක 14 දෙනෙක් වගේ බලලා තියෙනවා
ඕකේ අපි බලමු ඉම්ප්‍රූව් කරලා ගන්න කොහොමද
අපි එමුණොත් සර් මේ දැන් අද දැන් අපිට නයිට් ලෙක්චර් එකක් තියෙනවා එහෙම නැති වුණොත් මේ බලමු සර් අපි මේ 9ට විතර හරි
බලමු ප්‍රයිස් එක තමයි මට තාම මේ කන්සර්න් එකක් නැත්තේ ප්‍රයිස් එක හම්බෙච්ච ගමන් කියන්න හරියට ඒතර පොඩි අයිඩියා එකක් හැමෝටම දිනන එතකොට වැඩේ කරගෙන යන්න ප්‍රයිසින් එකම තමයි හැමදේම ඩිපෙන්ඩ් එක්සෑම් එකට ඩොලර් 200 ගාණක් යනවා ගන්න තමයි 210ක්ද කොහෙද
210 කියන්නේ මේ ලංකාවේ දැන් මුදලින් මම බැලුවා 61ක් වගේ යන්නේ
61ක් විතර වෙනවා ඔව්
එහෙමනොත් එහෙම ඔක්කොම ඉන්න ගානත් ඒ කියන්නේ කට්ටියම ඉන්න 35ම කරොත් නම් ඉතින් මේ MP එකත් එක්කම 70ක් විතරයි නේද 70ක්
ඔව් 60 ගියොත් ඔව් 70ක් 75ක් විතරයි අපි බලමු මේක කතා කරලා බලමු විදිහට එක කොහොමද කරන්නේ කියලා හරි okay so thank you very much I think you know about the scalable network so next week we will talk about the routing protocol so thank you very much if you have any clarifications if you need any information please my number is with the Sun no
yes
with the Sun and with the your batch representative yeah Sarinder so Sarinder okay Sarinder so if you have any clarification please text me or call me but not call me at midnight okay so call me before afternoon like that so thank you very much and we will meet on next Tuesday all right
okay
so thank you